welcome to our channel Knowledge of Friends. Subscribe to our channel and click the bell icon for the latest update. आज कंप्यूटर ग्राफिक्स की क्लास है जो कि कंप्यूटर ग्राफिक्स की क्लास 3 है. इस अगर क्लास की बात करते हैं तो दिस इज़ योर यूनिट 1 विच इज़ योर ग्राफिक्स डिवाइसेस एंड होपफुली आज के क्लासेस में हम ग्राफिक डिवाइसेस यूनिट 1 कंप्लीट कर लेंगे. लास्ट क्लास की बात करते हैं तो लास्ट क्लास में हमने 2 केसेस पढ़े थे जो कि लाइक इफ़ बोथ द लाइन आर पैरेलल देन द एंगल शुड बी 0 and if both are perpendicular then the angle should be 90 degree. We had end up with this, and first of all it's a huge request from my side to all the viewers, please go through with the subscribe button and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. In the today's class now we'll be going to start with another topic that is your in this unit only, and that is your line segment. So they had asked you about what is the line segment and also explain the length of a line segment as well. So let's go ahead here in a detail. Line segment. In the term of the line segment here, that any line or a pieces of a line having an endpoint is called the line segment, and we can find the equations of any line segment using its endpoints, and it can easily be checked that any point lies on the line segments or not. That points will be on the line segment that if your point satisfies the equation of the segment, and x coordinates of the point lies between x coordinate of the endpoint and y coordinate of the point lies between y coordinate of the endpoint. Then the parameters form of the line, we'll talk about it. The line here itself is, this is P1 and this is P2. In this, the parameters form of the line, that the parameter form of the line is expressed in the term of the parameter u, and this form of a line, this form is very important, especially when we consider about it. And when we consider any line segment, because it gives all the corresponding points of the line segment between 0 and 1, and where you the parameter u equals to 0, then it gives x1, and when u becomes 1 it gives x2, and that is x moves uniformly from x1 to x2, and the same in the case for y. And where the equation for this we have u is less than equals to, that 0 is less than is equals to u and less than equals to 1. For this, an equation that can be obtained from this, that we will be finding out with y minus that is your y1 and y2 minus y1, and in the same case the parameter has been established here. So the parameter will be y minus y1 upon y2 minus y1 equals to x minus x1 upon x2 minus x1, and which is equals to u. So then we will be finding out the equation. The first equation will get it, y equals to y1 plus y2 minus y1 and t. So here for the x1 as well we will get it, that is x equals to x1 plus x2 minus x1, and that is your t. That multiplies overall, and that they are the parameter forms of the straight line segment as well. Talking about the length of the line segment, and there is the length of line segment, we will talk about it. There is a line segment having the endpoints of like P1, which we had denoted here. This is your x1 y1 and this is your x2 y2. For that particular point we'll be showing in an axis, and then I will be finding out. So here that will find it out as L square equals to x2 minus x1 whole square plus y2 minus y1 whole square, and that will gives L equals to under root, square यहाँ से हटेगा तो under root लगेगा, and with the same concept, that is x2 minus x1 whole square plus y2 minus y1 whole square. And in the same reference towards it, now we'll go ahead to discuss about another question here, and that is a line segment has an endpoints of 2, 1 and 4, 2, and whether the given point 8, 4 lies on the line segment or not, that what we have to find it out. So let's go ahead to solve that. So the question is, a line segment has endpoints, which is 2, 1 and 4, 2. Find whether the points, which is 8, 4, line on this line segment or not. With this, so here that the equation of the line, will be writing out the equation of line, that is your y minus y1, and then I will be having 2 minus 1, this is your 2 minus 1 upon, that is 4 minus 2, and which is x minus 2 here. So in this, while solving it out, we'll get it 2y equals to x minus 2 plus 2, and then we will be getting it out is the other one, that is x equals to 2y. So putting x comma 4 to the above equation, which will gives 8 equals to 8 here only. If we'll giving the 8 here and 4 here, so if 4 to the 8, so it will be 8 equals to 8, and we satisfy the equation, and that is your where we'll be finding out the value as well. So where min x1 comma x2 is less than equals to x2, is it x3, and that is less than max x1 comma x2. So we'll satisfy the equation with this, and that is your 2, 4 less than equals to 8 and max 2, 4. So where value of 2 less than equals to 4, 8 and less than equals to 4 here. So this is what the value it is, and which violates the condition, and therefore the points 8, 4 does not lie on the line segment specified by 2, 1 and 4, 2 here. So that's what we have to represent it here. Now we'll go ahead with the another one, and that what we have to understood about it, and which is what do you understand by a plane, and also define an implicit form and explicit form of a plane as well. So first we'll discuss about the plane, and then we'll discuss about the implicit form and an explicit form as well. So let's go ahead here. First we'll discuss about plane. In the term of the plane here, that a plane can be expressed by a linear equation, and it is divided into the two classes, and where the two classes, as we know here, that is your implicit form, and the second is your explicit form. In the implicit form of the equation of a plane, that can be used to determine whether the 2 points are at the same or an opposite side of a plane here, with the same reference towards of a plane, and that is your given implicit form of the equation of a plane. We will be finding out is in the form of implicit form ax plus by cz plus t equals to 0, and where in the same case we have f x comma y comma z equals to a of x plus b of y by cz and plus t. So the two sides of a plane, whereas in the terms of r dash and r minus are determined by the sign of fx here, and that is your point x naught, y naught and z naught, all x0, y0 or z0, that lies on the region of r plus. And where in the same case talking about the explicit form here, explicit form of the equation is given by the following, which is named as z equals to ax plus by plus c. And now for a plane, we'll go ahead with a question here, that is for the plane 3x plus y plus 5z minus 12 equals to 0. So you have to check the points 1, 1, minus 1 that lies in which region, and that is r plus or r minus on the plane. We know that if we'll go ahead here with the question. For the plane 3x plus y plus 5 z minus 12 equals to 0. So check the point 1 comma 1 comma minus 1 that lies in which region, and that is r plus or r minus on the plane. So in this here that we know that if x0, y0 or z0 is greater than 0, then x0, y0, y0 or z0 is in r plus, or we can say that if x0, y0 and z0 is less than 0, then x0, y0 and z0 is in r minus region, or if x0, y0, z0 is equals to 0, then x0, y0 and z0 that is on the plane. And so calculating for fs, because I had mentioned you all the 3 possible situations, या फिर वो आपका 0 से छोटा होगा या 0 से बड़ा होगा या 0 के इक्वल होगा. On the same case I had write it down, and now we'll find it out the value, and then we'll get to know where it is lie. 3x plus y plus 5z minus 12, then we'll find it out for this. So that is your, take it as 1, y, x equals to 1 and y equals to 1, so that we'll get it f equals to 3 plus 1 minus 5 minus 12, and that is equals to minus 13, which is less than 0. So in this case, which is less than 0, so therefore the points we have 1 comma 1 comma minus 1, and that is in the region of minus r minus region, because that is less than, and which I had told you about it, that is comes under the second condition which we had mentioned here. Let's go ahead with the another one, and that's what we have to discuss about it. Explain the vector and character generations. In this vector and character generation, you have to be very considered about it, and in the terms of it, let's go ahead with the detail as well. So in the same case, we'll go ahead to discuss about it, and that is your vector and character generation. In the vector and character generations, talking about it, that the vector graphics is the use of the geometrical primitives such as points, lines, curves, and the shapes or the polygons, which are all based upon the mathematical equation to represent the image in a computer graphics. And vector graphics formats that are complementary to the raster graphics, and which is representations of the image as an array of pixels, as it is typically used for the representations of photographic image. And there are instances when working with a vector tool and a format is the best practice, and instance when working with the raster tools and format is the best practice. And there are the times when both formats come together, and understanding of this advantages and limitations of each technology and the relationship between them is most likely to result in efficient and effective use of tools as well. In the same case, the image to the left below in the representative of the bitmap, and that image of the right of the representative of the vector graphic, that they are the shown in the 4 times actual sizes of the exaggerate that the fact and that edges of a bitmap that becomes jagged as it is scaled up. So in the same case, if I'm talking about the bitmap images, that is a broad A has been represented, and a vector image that has been represented in a box here. So that a character generator, often abbreviated as computer graphics, is a device software that products the static and animated text as well, and such as crawls or rolls. And for keying into a video stream, that the modern characters that generate and computer based, and can generate the graphic as well as text as well. An integrated circuit usually in the form of the prompt, and that records the keystroke in a keyboard and output a corresponding character, that also referred to as a character generator as well. Talking about the vector generator, that here in the term of the vector generator here, that since intercepts of a line y that we have is your y equals to mx plus c, and where m is the slope of a line segment and c is the intercept on the y-axis, and both the endpoints are given for any line segment m, and then c is calculated as well. So in the same case, we'll be finding out m equals to y2 minus y1 upon x2 minus x1, and where c equals to y1 minus mx1 here. For any given x interval delta x along a line, that we can compute the corresponding intervals of delta y as, and that has been represented in the form of like m equals to delta y upon delta x, and we can say that delta y equals to m dot delta x here. So in this, that similarly we can obtain an x interval and x delta x corresponding to a specify delta y as, which has been represented as here like in the form of delta x equals to delta y upon m. And the other two types of the line generation algorithm, the first we will have the digital differential analyzer, which is DDA, and the second is your Branson sum line algorithm. So like I will go ahead here, the two types of line generation algorithm. The two types of line generation algorithm here we will be having, the first we have here is your digital differential analyzer, which is your DDA, and the second is Branson line algorithm. So in the same case, talking about it, and now we'll go ahead to discuss about describe the DDA line drawing algorithm and implement the DDA algorithm to draw a line from 0, 0 to 6, 6 here. So in the same case, we will be going ahead to solve it out, but the solution of the given problem will be solving after that. First we'll discuss about the DDA line drawing algorithm, and that has been represented here. DDA line drawing algorithm, and after that we'll solve a question here, that is for this only, that is your implement the DDA algorithm to draw a line from 0, 0 to 6, 6. In this, and the another question is also that has been asked as you explain, where that has been asked is explain symmetrical DDA with a suitable example. So let's go ahead with the detail here, that a digital differential analyzer, which is DDA, is a scan conversion line algorithm based on the calculating either delta x and a delta y, and we sample the line at a unit interval in one coordinate and determine the corresponding integer value nearest the line path of the other coordinate as well. And in the same case, that consider a line with a positive slope. If the slope is less than or equals to 1, we sample at unit x interval, that is your delta x equals to 1, and compute each successive y values as, and which is your y b plus h plus 1 1 that is equals to yk or plus 1 as well, and that has been represented like where k starting from 1 and increases by 1 until the final endpoint is reached, and since m can be any real number between 0 and 1, and the calculated y values that must be rounded to the nearest integer, and for lines with the positive slope that greater than 1, and we reverse the rule of the rule of x and y, that is we sample the unit of y intervals, which is your delta y is equals to 1, and that we calculate the succeeding x values as. And in the same case, the value x k plus 1 that is equals to xk plus in the representation of xk plus 1 is equals to x of k plus 1 upon m here. So above equation are based on the assumption that the lines are to be processed from the left end points to the right end point, and if this processing is reversed, so that the starting end point is at right, and then either we have delta x equals to minus 1. So the equation of this will be finding out in the terms of y as your yk plus 1 equals to yk minus 1 m. So this has been represented, or when the slope is greater than 1, then we have here that is your delta y is equals to minus 1, and with this then we have your xk plus 1 is equals to xk minus 1 upon m here. So solution of this particular problem, that what we have to solve it out. So let's go ahead to solve with it. So compute the initial value of this. So we'll be getting it delta x equals to x2 minus x1. So we have an x2 here, and that is your 6, and that is 6 minus 0. 6 minus 0, which is equals to 6. And for the another one for delta y, which is equals to y2 minus y1. So in this 6 minus 0, which is also equals to 6 here. And finding out m here, so that is your delta y upon delta x, which is equals to 1. So delta x equals to 1 as well, and yk plus 1, and which is equals to yk plus m. So now we'll go ahead to make a table as well, and that has to be as follows. There is the steps will represent, that is your 1 2 3 4 5 and 6, and then we'll be having x values, then we have value y, and then we have a pixels as well. So in this, when we will have 0x and then 0y, we will be getting a 0 comma 0 here paired, and then a pixel here. This is your 1, this is your 1, which is 1 comma 1. Then we have 2, value of 2, we have value of 2 comma 2, 3, 3, 3 comma 3, and then that is your then we have 4, and then we have 4 comma 4, then we have 5, 5, then we have 5 comma 5, and then we have 6, 6, then we have a 6 comma 6 here. So here then we'll represent in the pixel position. So here we'll draw an axis here that has been represented. This is an origin. So 1 2 3 4 5 and 6, and this is 1 2 3 4 5 and 6. So we will represent it as 0 comma 0. So here it is 1 comma 1, this is 2 comma 2, this is 3 comma 3, this is 4 comma 4, this is 5 comma 5, this is 6 comma 6 here. That has been represented here in the form of the representations of an axis here. In this, now we'll go ahead to discuss about the second one, that is your Prehensen's line algorithm. In this, that the question has been asked in the form of like write the Prehensen algorithm of a line and explain of 5 marks, and the another question is write steps required to draw a line from the point x1 y1 to the x2 y2 and using the Prehensen line drawing algorithm. And for that, that the describe Prehensen line algorithm drawing algorithm for the 10 multiply 10 frame buffer and interpret the Brehemsen algorithm by the handle to find out the pixel and turn onto the line segment, which is 1, 2 and 7, 6 as well. That's what we have to represent it here. And another question what they can ask you is in the reference towards it, and that is to compare the digital differential analyzer with the Brehemsen line drawing algorithm. So let's go ahead to discuss about it, which is your Brehemsen line drawing algorithm. In Brehemsen line drawing algorithm, to illustrate that Brehemsen approach, we first consider the scan conversion process of lines with a positive slope less than 1 and the pixel position along a line path that are then determined by a sampling at a unit x interval, and starting from the left end points, which is your x, x0 and y0 of a given line, and we step to each successive column, which is an x position, and plot the pixel whose scan line y value is the closest to the line path. We are given figure demonstrator with the keyth step in the process as well, and we are assuming we have determined that pixel of x y is to be displayed. We must decide the pixel to the plotter as well. In the same decision parameter, which has been represented by the pk with the kth step of the line, that along with the obtained rearranging the equation, so that involves only the integer calculation, where in the same case Brehemsen's line drawing algorithm will be in the process of like to input the two lines endpoints and store the left endpoints, which is your x, 0 and y0. In the same case that we have to load x0 y0 into the frame buffer, that is your plot first point, and then calculate the constant of delta x, delta y, 2 delta y and delta y minus 2 delta x to obtain the starting value for the decision parameter as well. Where otherwise the next point plots, we have to find it out and repeat, we'll have to repeat each and every step. And solution of a given problem, that will be finding it out what the problem is all about. So let's go ahead to write about the problem and then we'll solve it out. So the problem is describe Brehemsen's line drawing algorithm for 10 to x 10 frame buffer frame buffer, that is intercept, interpret the Brehemsen's algorithm by hand to find which pixel are turned on for the line segment 1, 2 and 7, 6. So now we'll solve this particular question, and so that we will be getting out the solution as well. So the solution we have, where delta x equals to x2 minus x1, and in the same case for x2 minus x1 we will be having 7 minus 1, which is equals to 6 here. For the another one, for the delta y, which is equals to y2 minus y1, which is equals to 6 minus 2, which is equals to 4 here. And for the increase, that is of c1, which is your c1 equals to 2 delta y, and that is equals to 8, because this is 4 and 4 2s are 8, so the answer would be the 8 here. And for the another one, that is for the c2, so 2 delta y minus delta x, so there 2 delta y is your 2 to 4, and delta x is your 6, which we had to find it out. So here, and which is equals to 4 minus 6, that is your minus 2 multiply 2 to the 4 minus sign, so minus 4 here. Now we'll find it out here, that is p0, that is your 2 delta y minus delta x, which is equals to 4, this is 4 2s are 8 minus 6, that is equals to 2 here. In the same case, when we are going to further solve it out, let's go ahead to make a table here, and that is steps. And then we have here is your, that is p of k, and the pixels. So the steps we have here till 5, 1 2 3 4 5. And now we'll go ahead here as well. So in this of px we have your 2. First we have 2, so here that is 2 3, then minus 2, so we have 3 3, then we have 6, we have here that, yeah, see, that is your 6, and then we have your 4 4, then we have your that the another one is your 2, then we have 5 5, and then we have your minus 2, so we have 6 5, and then we have 6 here, that is your 7 6. For the pixel that representing in a pixel form, so we'll be having an axis here. This has been representing 1 2 3 4 5 6 and 7, and this has also been represented here 1 2 3 4 5 6 7. So in the same case, we'll represent each and every column here. So the first is your 1 2, and that has been represented here. So the 1 2 here, which is 1 2. Then we have the another one, which is your 2 3. So the 2 3 is 2, and this is 3 2 3. Then we have 3 3. So the 3 3 is here, that is your 3 3. Then we have your, the another one is your 4 4. So 4 4 we have here, that is your 4 4. And then again we have your another one, this is your 5 5. So 5 is here, and this is 5, so this is your 5 5. And then we have your 6 5, so 6 here, and that 5 here, so this is your 6 5. And then we have your 7 6, so 7 here and 6 here, so this is your 7 6. This is the representations of that what we had find it out the pixels here. Let's go ahead with another one, and that what we have here, the another question as well. And in the same case, what we have to solve it out with this reference towards it. The question we have is to develop and write the Brehemsen's algorithm of line, and also predict the pixels of a line from 2, 2 to 12, 10, and using this algorithm you have to find it out. So this is of 7 marks, and which we have to find it out. So let's go ahead here. That the question is develop and write Brehemsen's algorithm of line, also predict the pixel on the line from 2, 2 to 12, 10 using this algorithm. Let's go ahead with the solution here. In this Brehemsen algorithm of line that we had even though discussed in a detail as well, let us predicate the pixels of line of 2, 2 to 12, 10, and by using the Brehemsen line drawing algorithm. So where will be having is your x1 equals to 2, y1 equals to 2, x2 equals to 12, and y2 equals to 10 here. In the same case, the delta x is equals to x2 minus x1, and which is equals to 12 minus 2, that is equals to 10. For delta y, we have equals to y2 minus y1, and which is equals to 10 minus 2, and that is equals to 8. The slope of the line will find it out, that is m equals to y2 minus y1 upon x2 minus x1. So that we are putting the value here, 10 minus 2, and that is your 10 minus 2 upon 12 minus 2. So 10 minus 2 upon that is 8, 8 upon 10, so that is your 0.8 here. So the initial decision parameter that will find it out is your p0 equals to 2 delta y, which minus delta x, and we will say that p0 equals to 2, that is equals to 2 or multiply 8, that is minus 10. So which is equals to 8, because 8 to the 16 minus 10, that is just 6. And in the same case, that the increments for calculating the successive decision parameters, that are of delta 2 delta y and minus 2 delta x, which is 16 minus 20, which is your that is, we'll find it out, 2 delta y minus 2 delta x, which is 16 minus 20 equals to minus 4. And another one is 2 delta y, that is here, that 2 delta y equals to 16 here. So plot the initial plot of x0 and y0, which is 2, 2, and successive point that can be tabulated here. So we'll find it out the table here, where we'll have steps, then we have pk, and then we have pixels. So here the steps we have the px and the pixels as well. So steps we have from 0 until 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the px, now we'll put the value. If pk is your 6, then the pixel is 3, 3. If the that the px in the step 1 is 2, then we have 4, 4. We have minus 2, then we have 5, 4. If we have your 14, then we have 6, 5. And if it is 10, then we have your 7, 6. If it is 6, then 8, 7. If it is 2, then we have your 9, 8. Minus 2, then we have 10, 8, and if it is 14, then we have 11, 9, and if it is 10, and then we have 12, 10 here. So that has been represented in the form which is used here as well. So now we'll go ahead with the graph that has to be represented here. So let's go ahead. This is from 13 to 13. So here this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so this we have your 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 13. So in this we'll represent it here, that is the first is your 2, 2, then we have 3, 3, then we have 4, 4, then we have 5, 4, then we have 6, 5, and then we have your 7, 6, 7, 6, that is here. But then we have your 8, 7, so 8, 7 is here. Then we have 9, 8, so here. Then we have 10, 8, so here 10, 8 is already here only. And then we have 11, 9, so this is here. Then 12, 10, that is here. So this has been representing a diagram which has been representing, the using this algorithm. We'll be finding out to predict the pixels with the form of the table, and then after that shows into the pixel forms here as well. Now we'll go ahead with another one, and that another question, that is the using Grahamson line drawing algorithm, draw a line whose endpoint is 4, 4 and start point is -3, 0. So for that we'll have to draw it. So let's go ahead here. The question we have here is that is using Grahamson's line drawing algorithm, draw a line whose endpoint is 4, 4 and start point is -3, 0. So this is 5 marks. So here we'll go ahead here, where x1 is -3 and x2 is 4, and where y1 is 0, and then y2 is your 4 here. So that has been represented, and we'll find out the value as well. So that is your x1 equals to -3, x2 equals to 4, and y1 equals to 0, and y2 equals to 4 as well. So let's find it out for the delta x, and that is delta x equals to x2 minus x1, which is equals to 4 plus 3, that is here equals to 7 here. And for the delta y, that is equals to y2 minus y1, which is equals to 4 minus 0, and that is equals to 4 as well. For the c1, if I'm talking about, that c1 is 2 delta y, which is equals to 8, because that is 4 and 4 multiply, that is 2, 4 2s are 8 as well. For the c2, we'll be finding out 2 delta y minus delta x, and that is your c2 is equals to 2, 4 minus 7, and that is equals to -6, because 4 minus 3, 2 is 6 with minus sign here. So now for the p or not, that is of p0 with 2 delta y and minus delta x, so that is equals to 2 into 4 minus 7, that is equals to 1 here. Now we'll form our table here, and here we'll have to form many, that is will be representing in the form of the steps x, y and px in the pixels as well. So let's go ahead. Steps x, so here after x we'll be having a y, then we have p of k, and then we have pixels. So the steps we have is from 0 to 6, 0, 1, 2, 3, 4, 5 and 6, And so we'll go ahead with the values as well. So here with this, when we'll have minus x and y is equals to 0 and px is 1, then we have a pixel that is your minus 2 comma 1. When we have x minus 2, this is your 1, then this is your minus 5, and that is your minus 1 comma 1. If it is 2 in the step, that is your minus 1, it is your 1, and this is your 3. So the comma pixels we have 0 comma 2. This is 0, this is 2, this is minus 3, then we have 1 comma 2 here. This is your 1, this is 2, then we have 5 here, and that is 2 comma 3. And after that we will be having, this is your 2, this is the 3, and this is your minus 1, so this is your 3 comma 3. And in the same case, this is your 3, this is 3, this is 7, then we have your 4 comma 4. This is a solution which has been asked for 5 marks here. Let's go ahead with another question here, and that is that what are the criteria that should be satisfied by a good line drawing algorithm? You have to explain, and this question has been asked for 6 marks possible questions. So let's go ahead to discuss about it. So here the question is the criteria that should satisfy by a good line drawing algorithm. In this, a line drawing algorithm that is generated by a line that should be having a following characteristics that we'll talk about. The first characteristic is that line should appear straight. Lines should appear straight. And this line should appear straight here, that the lines generated parallel that to the x-axis and a y-axis or at 45 degree are fine when plotted with a points, that plotting technique. Other lines that cause a problem, and although the starting and the finishing points are plotted correctly, the line may not pass through the other addressable points in between, and in such cases it is the best approximate the line by choosing the addressable points close to it, and otherwise we shall produce the jagged or the crooked lines as well. The second we have is that is line should terminate accurately. The lines should terminate accurately. If the lines are not plotted accurately, they may terminate at a wrong place, and this may lead to a small gap between endpoints of a line and the starting points. That next in this, that you can see that the effects of the endpoints termination should be like in the forming, like when we are drawing a triangle and then we'll drawing a rectangle as well, so they have endpoints as well. So this is the effects of the endpoint in the terminations. The third criteria, the third characteristics that it follows is the lines should have constant density. In this, line should have a constant density is to maintain the constant density throughout the line. The dots should be equally spaced, and the line density is proportional to the number of the dots displayed divided by the length of the line as well. And the dots are equally spaced only in the line are parallel to an x-axis and a y-axis, or at 45 degree to the axis. So that has been represented in the form of like this. They are spaced between it, so that spacing of the dots should be remain there. Let's go ahead with another one, and that is the fourth characteristics we have, and that has been represented here. The fourth characteristic is line brightness independent of slope and line length. So here in this requires a high resolutions of the devices along with the high refresh rate as well. So in the same case, let's go ahead with another one, and that what we have to discuss. The another one is the fifth one, and that is your lines should be drawn rapidly. In this in iterative application, that interactive application, the lines should appear rapidly on a screen, and that is the minimum computations is desired to draw the line as well. And now we'll go ahead to discuss about it, where we'll have to discuss the question is that write a line type procedure by modifying the Brehenson's line drawing algorithm and to display the either solid, dashed or the dotted lines as well. So for that we'll be having some steps here, 5 to 6 steps as well. So in the same case, the first is that to set the initial value, and where the x1 and y1, that is the start of the line, and x2 and y2, this is the end of the line as well. And where the a is to be represented as the tan inverse, which is y2 minus y1, and upon x2 minus x1, that will find it out, and the d is the length of the dash, and the c is that is the length of the blank as well. In the second step, we will be having to find it out as to see whether the entire line has to be drawn, and if x1 is greater and equals to x2, then stop. And in the step 3, that to compute the end of the dashes, and that is to x2 equals to x1 plus d cos a, and where y2 is equals to y1 plus d cos a here. In the step 4, that to send x1 and y1 and x2 and y2 that to a line routine and a plot dash, and in step 5, that to compute a starting point of the next dash, which is x1 equals to x2 plus c cos a, and y1 is equal to y1 y2 c assign a here as well. And then we'll go to the step, then again we'll go to the second step here. Now we'll talk about the another question, that is to discuss the circle generation algorithm in detail. In the circle generation algorithm here, that what we have to find it out, and a circle is defined as a set of the points that are all in the given distances r from the center point, which is x1 and that is x of c and yc. That's we'll draw a figure for that as well. The distance relationship is expressed in the Cartesian form, in the form of like x1 minus xc ka whole square plus y minus yc whole square equals to r square. And this we could use this equation to calculate the position of the points on the circle's circumferences by stepping along the x-axis in unit steps, and where the xc minus r or xc plus r, that calculating the corresponding y values of each position, and that has been represented in the form of y equals to yc plus minus under root r square minus xc minus x whole square. And with this, but this is not the best method for generating a circle. One problem with this approach is that it involves the considerable computations at each step, and moreover the spacing between the plotted pixels positions is not uniform. In the same case, we're talking about that the another way to eliminate the unequal spacing is to calculate the points along with the circular boundary, and using the polar coordinates r and 0, and that the expressing the circle's equations in the parameter polar form, and that yields to the pair of the equation as well. In the same case, which is x equals to xt plus r cos theta, and y equals to yc plus r, that is sin theta. When a display is generated with these equations using a fixed angular step size, and a circular is plotted with an equally spaced point and that the circumference, and although the polar coordinates provides equal point spacing, and the trigonometric calculation are still time consuming for any of the previous circle generating method, We can reduce the computations by considering the symmetric of the circles, and the shape of the circles is similar to each quadrant as well. And therefore, if we determine that the curve position in the first quadrant, we can generate the circle sections in the second quadrant of the xy planes by noting that the two circle sections are symmetric with respect to the y-axis, and the circles that section in the third and the fourth quadrant that can be obtained from the section, and in this and the second quadrant where the constituents symmetric about the x-axis. And we can take that this is one of the further. We can note that there is also a symmetric between the that is your octants circle sections in an adequate octants within one quadrant are symmetric with respect to the 45-degree line dividing the two octants as well. And these symmetric conditions are illustrated in the figure like we'll discuss in the form of the circles. And when a point of the position x comma y on a side 1/8 circle sector is mapped into a 7 circles that that points to a symmetric in this way, and we can generate all the pixels that positions around to the circle by calculating only the points within the sectors from x comma 0 to x comma y here. In the same reference, now we'll discuss the midpoint circle algorithm in a detail, and in the same reference towards it that explain the midpoint circle generating algorithm. So let's go ahead here. Midpoint circle algorithm here, that is as in the rasters line algorithm, we sample at unit interval and determine the closest pixels positions to the specified circle at an each step, and for a given radius and the screen center position, that is your xc and yc. We can first set up to our algorithm to calculate the pixel position and around a circle path centered at a coordinate origin 0, 0. Then each calculated the positions x, y is moved to its proper screen position by adding an x to x, c to x and yc to y, and along the circle sections from x equals to 0 to x equals to y, and in the first quadrant, and the slope of that the curve varies from 0 to -1 and 0. And then of course therefore we can take the unit and the positions of the x directions that over this octant, and that the use of the decision parameter that to determine which of the two possible y positions are the closer to the circle, but at each step. So positions in the other that other 7 octants are then obtained by the symmetrically, and to apply the midpoint method, we define a circle function as well. With the circle function, that what we define is your f circle, that is x comma y equals to x square plus y square minus r square. So this any point x comma y on the boundary of the circle with the radius r that satisfies the equation f circle x comma y equals to 0, and if the point is in the interior of the circle function is negative, and if the point is outside the circle function is positive as well. In the same reference towards x square plus y square minus r square equals to 0, that has been represented here. So if the function of x comma y is less than 0, then if x comma y is inside the circle boundary, and if it is equals to 0, then is on the circle boundary, and if it is greater than 0, then if it is outside the circle boundary here. That shows the midpoint between the two candidates, that pixel that sampling the position which is of xk plus 1, and assuming that we have just plotted the pixel at xk and yk, we next need to determine whether the pixels at the position xk plus 1 and yk on the one of the position, and that is closer to the circle. So the decision parameter is the circle function equation that is evaluated as a midpoint between these two pixels as well. So we are talking about those pixels. So here we'll have px equals to f of circle, and that is xk plus 1 yk minus 1 by 2, and that is equals to, you can say that xk plus 1 square plus yk minus 1 by 2 square minus r square. In this, if p of k is less than 0, then this point is inside the circle and the pixels on scan line of yk is closer to the circle boundary, and otherwise the mid positions is the outside are on the circle boundary, and we select the pixels on the scan line, which is yk minus 1. So successively decision parameters are obtained using the incremental calculation, and we obtain a recursive expression for the next decision parameter by evaluating the circle functions in the sampling pattern. And in the sampling pattern, which is xk plus 1 plus 1, and that is of xk plus 2 here as well. In the same case, that depending on the signs of pk, that has also been represented here. And in the same, while in the same case talking about also in this, that incremented for obtaining that pk of the either of the side of the negative, that the evaluations of the terms that can also be done incrementally, and at the start position 0 comma r. So these two terms have the values that 0 and 2r, that respectively each successive values of the 2x k plus 1 term is obtained by adding a 2 to the previous values, and each successive values for 2y k plus 1 terms is obtained by subtracting 2 and from the previous value as well. So here we'll summarize the steps in the midpoint circle algorithm as to be as follows. Like first we have to input the radius r, that the circle center xc and yc, and then set the coordinates for the first point on the circumference of the circle centered on the origin, which is your x0 y0 equals to 0 comma r. Then you have to calculate the initial value of the decision parameter, which is p naught equals to 5 by 4 minus r. Then at each x k position starting at k equals to 0, then perform the following test. If pk is less than 0, then the next point along the circle centered on 0 comma 0 is your x k plus 1 and yk, and then we'll put the value for pk plus 1 equals to pk plus that 2x k plus 1 equals to plus 1 as well. Then in that same case, you have to determine the symmetric points in the other 7 octants and move each calculated pixel position, which is x comma y, onto a circular path centered on xc and yc on the plot coordinates as well. And then of course we'll have to repeat the step 3 and 4. Now we'll go ahead with another question, and that what we have to discuss as well, that is the write a midpoint algorithm, and that predict the pixels and octant circles of the radius, which is 10 pixels with the center of the origin here. So in the same case, we'll go ahead here, that is write a midpoint algorithm and predict the pixels of the octant of a circle of radius 10 pixels with the center of origin. And even though for the midpoint circle algorithm we had even though discussed here, so let's go ahead with the question that has been asked, and you have to predict the pixels . The question is predict the pixel in any octant of circle of radius equals to 10 pixels with its center at origin. So in this, the radius r equals to 10 and the center is 0 0, and let us compute the positions along the circle in the first quadrant from x equals to 0 to x equals to y, and the initial value of the decision parameter, which is your p naught equals to 1 minus r, that is equals to minus 9 here. And in the same case, we'll go ahead with the starting point, which is x0 y0, that is equals to 0 comma r, and that is equals to 0 comma 10, that has been represented here. So let initial incremental terms for the calculating a decision parameter, that are 2x0 that is equals to 0 and 2y0 is equals to 20 here. So the successive points for that can be tabulated here, so we'll find it at the table here. Steps, we have steps 0 1 2 3 4 5 and 6. Then we have px, then we have xk plus 1, and y k plus 1, then we have 2x k plus 1, and then we have your 2y k plus 1. So here in this we'll put the value and then we'll find it out the value as well. So in the same case, so here for all the 6 values which we have 9 is minus 9, then we'll have 1 comma 10, and then we have 2x k plus 1 is 2, and that is 20. This is, if it is minus 6, then we'll be having 2 comma 10, 4, and then 20, minus 1, then we have 3 comma 10, 6, and 20. If it is your 6, then that is 4 comma 9, 8, and 18. Then we have minus 3, and we have 5 comma 9, 10, and then we have 18. If it is 8, then it is your 6 comma 8, and then we have your the 12, and of course this is your 16. If it is 5, then we have 7 comma 7, and this is 14, and this is 14 as well. So this will be the answer. Now we'll go ahead with the question, the another question, that plot a circle centered at 5 comma 5 and having a radius of 5 units using a midpoint circle algorithm here. In the same case, for that sake, we'll be having to find it out the values as well, and we'll put the value as well in the form of a table. But before that, we'll discuss one of the things, that is what are the causes of the corruption of display files. So let's go ahead. The causes of corruption of display files. In the corruptions of the display file, the causes of the corruption of display files here: when an image fails to display properly, the causes might be any or all of the following: the display environment, that is your drivers, video memory, display resolutions is not properly configured or is inadequate; the file format is not supported by the display program, and the variations of the file format is not supported by the display program as well; and that the display program is incorrectly interpreting the file, and the file data is bad or corrupt, that has been represented here. So now we'll go ahead to explain the parallel version of line algorithm in 2 methods here. So that we'll discuss here. Parallel version of line algo by 2 methods. So in this, that in the parallel algorithm that has been asked of 10 marks, and in a parallel versions of line algorithm, that the pixel positions are calculated along a line path of similar simultaneously by partitioning the computations among the various processors available. And we have said that NP, that the processor we have a parallel Brennison line algorithm that can use for the subdividing a line path into a NP partitions, and the simultaneously generating the line segments in each of the sub intervals for a line with a slope, and that is 0 or less than that is m, and that is great less than equals to m as well, and that is equals to 1 as well. The left hand coordinate which x is 0 and y is 0, that the line is a partitions along the positions of x directions, and that the distance between the that a beginning at x position of the adjacent partition is has to be as calculated here. That is delta xp equals to delta x plus np minus 1 upon np, and which is where the delta x is a width of the line and the values of the partitions width, and the delta x of p is computed using integer division, and the starting of the x coordinate is calculated as the kth partitions, which is represented by the x of k, that is your equals to x near plus k delta x of p. And for example, for delta x equals to 10, 15 and np equals to 4 processor, and then the width of the partitions is 4, and the starting x values of the partition are x0 and x0 plus 4, or x0 plus 8 and x0 plus 12 as well. If the line endpoints are not integer, then the truncations error results in the variable width of partitions along with the length of the line, And to apply the Abrahamson algorithm over the partitions, the initial value for the y coordinate of the initial value of the decision parameters in each partitions are needed, and the change the delta y of v is in the y directions over each partitions is calculated from the line that is slope m is the partition width as well, where the delta yp is equals to m delta x, and at the kth partitions the starting y coordinate is your yk equals to y0 plus round, and that the initial value as well. And in the same case, that each processor that calculates the pixel positions over its assigned subinterval using the starting decision parameter values, that is the subinterval of the starting coordinates as well. Let's go ahead with the doing another question, and that is the last question of the session as well. So the question we have is to plot a circle centered at 5, 5 and having a radius of, I will just write it on first question. Plot a circle centered at 5, 5 having radius of 5 units and using the midpoint circle algorithm. So we shall first compute the points on the first octant from x comma 0, and to find out that x equals to y here, and then of course then plot that is to plot the other octants points based on the symmetry. The first points that to plot this we have, that is your x naught plus x naught and y naught plus y naught, which is 0 plus 5 and r plus 5, which is equals to 5, 10 as well. In the same case, the initial decision parameters for this will be having that is p naught equals to 1 minus r, which is 1 minus 5, which is equals to minus 4 here as well. So we'll just form a table here, that is k, pk, then we have xk plus 1, yk plus 1, 2xk plus 1, 2yk plus 1, and then we have actual points, which is xc plus x and yc plus y. So let's go ahead with the k here, 0, 1, 2, 3, 4 here, the values will, and this is your minus 4, which is 1, 5, 2, 10, and then we have a formula that is 6, 10 here. Then other than that, we'll be having another value. This is your minus 1, which is 2, 5, and this is 4, this is 10, and this is your 7, 10 here. This is your 4, this is 3, 4, this is your 6, this is 8, and this is 8, 9. Then we have the another one, that is your 3, 4, 3, and this is your 8, 6, and this is 9, 6, and which is your 6. Then you have your 5, 2, then 10, and then 4. This is your 10, 7. So here that is we can say that the x5 is greater than y5, so the algorithm will not proceed here. So in this that will end up here. So first of all, it's a huge request from my side to all the viewers, please go through with the subscribe button, and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. In this we have 4 units here. So the first unit is your graphic devices, which we had end up in this class. This is your introduction and line generation, types of the computer graphics, graphic display, random scan display, raster scan display, frame buffer and a video controller, pointer and the lines, and the line drawing algorithm, the circle generating algorithm, midpoint circle generating algorithm, and a parallel versions of these algorithms as well. In next class we'll start with your unit 2, that is your transformation, which is your transformation, basic transformation, matrix representations of the homogeneous coordinates, composite transformation, reflections and shading, windowing and clipping, viewing pipeline, viewing transformation, 2D clipping algorithm, line clipping algorithm such as Cohenson that is your Sutherland line clipping algorithm, Liang-Barsky algorithm, Liang clipping against a non-rectangular clip window, and as well as the polygon clipping, Sutherland Hodgman polygon clipping, and a Wellman and Atherton polygon clipping, curve clipping and a text clipping. In unit 3rd we have to cover up 3 dimensions, which is 3-dimensional, 3D geometrical primitive, 3D objects representation, and 3D transformation, and the 3D viewing, projection and 3D clipping as well. In unit 4, the curves and the surfaces, where the curves and the surfaces, quadratic surfaces, spheres, ellipsoid, blobby objects, introductory concepts of the spline, B-spline and Bayesian curves in surfaces, hidden lines in the surfaces, backface detections algorithm, depth buffer method, and a BAPE, that is a buffer method, and scan line display, basic illumination method, ambient light, diffuse reflections, spectacular reflections in a Phong model, combined approach, bond model, intensity, attenuations, and the color considerations, transparency in the shadow as well. So first of all, it's a huge request from my side to all the viewers, please go through the subscribe button and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. You will be provided each and every video here, that is your computer graphics, principle of programming languages, the data warehouse, and the economics will start with, and that is the another one will be reasoning, and of course the quantitative aptitude, DBMS, that all we are doing here in this present time. So thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.